Hi, good morning, guys. Today, the topic we are going to see about is design principles. Design principles and design patterns both are different concepts. Don't confuse one with the another. Design principles are the general guidelines or best practices that are used in the software development system. So, due to the best practices or guidelines, you can make the good design decisions. You can build up the good system due to these practices. But design patterns, in the sense, they will be like the solution for the common recurring problem. So don't confuse design principles with the design patterns. You will see about the design patterns in my next video. So in the case of design principles, these are the general guidelines for the best practices. So there are a lot of design principles. For example, there are solid principles, kiss principles, dry principle, jargony principle, favor composition over inheritance principle, encapsulate what varies principle. So there are a lot of principles like this. So let's see one by one. Okay. So these are the high level concepts that help developers to make decisions about the structure, organization, and behavior of the system. So let's see one by one. First, let's see about the solid principle. As the name suggests, solid, it complies with the five design principles because the word solid, SOLID, each five letter define five principles. So, S for the single responsibility principle, O for the open or closed principle, L for the list of substitution principle, I for the interface segregation principle, and D for the dependency inversion principle. So let's see these five. First of all, single responsibility principle. As the name suggests, it means the class should have only one responsibility. That means it has only one reason to change. It has to do only one function. So, due to that, it will break the complex system into smaller manageable components because one class should do only one thing, only one function. The class should change only for one reason. So we are dividing into smaller manageable parts. So that's what we are doing in the single responsibility principle. And in the case of open or closed principle, here also name suggests open. Open for what? Open for extension. Closed. Closed for what? Closed for modification. So as the name suggests, open or closed principle means it should be open for extension but closed for modification. So, in the sense of extension, you can add the new functionality. That means you can extend the system. You can add some implementation through the interface. You can extend through the inheritance. So you can add new functionalities using those features like abstraction, inheritance, like those functions. But you can't change the existing code. If the code works fine, you can't touch it further. You can't make any modification to the existing code base. So, should be open for extension but closed for modification in the sense you should able to add new functionality to a software system without changing the existing system, existing code. So, in this example, here I created shape as the interface and I created class rectangle and class circle by implementing the interface shape. Thereafter, I create the function called area calculator. And in the area calculator, I am passing the shape. So when I call this area calculator class, I will pass what the class I want. Like I will pass rectangle or circle or whatever I want. So If I want to add a new class like triangle, you can surely add it, but you will not make any changes over there. Like shape and rectangle, all the things are fixed. Even you don't need to make any changes in the area calculator, because here also you are passing the common things like shape, here shape. So you are not passing anything here, anything specifically. So you can easily modify them. That is, sorry, you can no need to modify them, but you can extend them by adding new class like triangle or sphere, or you can add anything, any class you want, but you will not change the code. So this principle, open or close principle, is similar to the last principle, that is dependency inversion principle. So second one, open or close principle and dependency inversion principle, both are similar concepts. When I see the fifth one, let's see about that. Now let's move into the third principle, that is Liskov substitution principle. This means that subclasses can be used to substitute their superclass. Normally, you know, subclass and superclass are the concept of inheritance. So that means that normally what will comprise of the superclass, that means functions, variables, all will be inherited to the subclasses. So by using the subclass, you will be able to substitute the superclass. Derived class, that means derived classes must be substitutable for their base class. Derived class means subclass, and base class is the superclass. And the fourth principle is the interface segregation principle. This means that clients should not be forced to depend on methods they do not use. That means client code only depend on the method what they want to use. This means that, for example, you have the animal interface. And on the animal interface, you are writing the function for flying and for running. But when you are calling the dog, you will only depend on the running function. And when you are calling parrot, you will only depend on the flying function, not on the running function. So, when you are calling parrot, you are implementing the animal interface. So, you need to depend on the running method as well. The same thing happens for the dog class as well. So, here what you need to do is, instead of creating the animal interface, you need to create specific interfaces like as the running land animals or terrestrial animals and the birds. Like that, you have to create two specific interfaces without depending on the single generic interface. So that interface segregation principle states that many specific interfaces are better than the general interface. So instead of creating the animal general interface, it's better to create terrestrial animals and birds, two specific interfaces. So clients should not be forced to depend on the methods they do not use. So this means that it encourages developers to break down large interfaces into small, more focused interfaces. That means specific interfaces with specific features, not with all the features. And the last principle, that's for D, that's the dependency inversion principle. As I have stated, it is similar to the second one, that is open or closed principle. That means that it is depend upon abstraction, not the concretion. That means that That means that depends upon abstraction, not concretion, means that you are not depending on the fixed implementation. You are just depending on what you have just stated. That means what are the behaviors you stated, not on the implementation. That means higher level modules should not depend on the low level modules. Instead of that, both higher level modules and the low level modules should depend on the abstraction. You already know abstraction means you are just only stating the behaviors. You are not implementing that. That is abstraction. So both modules should depend on the abstraction. Not high level modules depend on the low level modules. Okay. So for example, let's take the scenario where the high level module A depends on the low level module B. So A is dependent on the B. So if B changes, what will happen to A? It will be affected, right? Because A is dependent on B. But according to this principle, what you need to do is, if both A and B depends on the interface or abstraction, any changes made to B wouldn't affect A because it is both are depends on the interface. Now not A is depend on the B. So by changing B, it will not affect A because now both are depend on the interface. Okay. So it will allows for the loose coupling and easier maintenance. So here, if you see, here I have created iData access interface and I have make the concrete implementation of the class SQL data access and XML data access. And here I have created data processor, and for the data processor, I am passing iData access. That means this interface. And in the client class only, I am calling what I need. I mean SQL data access or XML data access. So now a data processor class depends on the interface iData access, not on the SQL access or XML data access. Because both are the concrete implementation, SQL data access and XML data access. So, the data processor only depends on the interface iData access. So, by passing client code what I need, I can make the change here. Since both are not depends on the both are not depends on the concrete implementation. Here, the second principle also same, open or close principle. Here also what we do, we are defining interface and here we have created two concrete classes. And here that area calculator is depends on the interface, not on the concrete implementation. Because due to the interface, we can able to extend the class, but we don't need to modify that class. So here what this means that all the principles are related to one each. Open or close principle is related with the dependency inversion principle. So all the principles are related to one another. So here we have seen these 5 principles. If you see again, solid principles means 5 principles. S for single responsibility principle, as the name suggests, it only complies with the one function. Each only one responsibility should change for only one reason. O for open or close principles, that means open for extension, close for the modification. That means you can add new functionality, but you cannot change the existing code base. So you need to do it through the abstraction, that means interface. L for list of substitution principle, that means you subsystems are able to replace the substitute the base class, that means superclass. And interface segregation principles means you need to segregate, that means separate the interfaces into more specific things. You cannot make the generic interfaces. You have to add the specific interfaces. And D again for dependency inversion principles. That also again the same concept. That means high level modules should not depend on the low level modules. Both modules should depend on the abstraction. So these are the 5 principles in solid principle. And this is one example for the design principle. Now let's move into the second design principles, that is encapsulate what varies. Okay. So encapsulate what varies. As the name suggests, you have to encapsulate the things what really vary. So here you are doing that, you are encapsulating in you already know in the WOP concepts you have 4 things, that is encapsulation, inheritance, polymorphism, um, abstraction. You can able to see these 4 concepts in my previous video. If you haven't seen that, you can able to see that in my previous video. And so encapsulating means hiding. So normally encapsulation is used for the hiding of the sensitive data. That means binding all variables and methods in the one single class unit. So here encapsulating or hiding the implementation details that will likely to change in the future. So what you need to do here is, if you think you are going to change one feature in the future, one behavior, that means one feature, one method. So you need to change that on the future. So you have to separate it to another separate class. So it will not affect other parts of the program. Okay. Um, so this principle suggests that identifying the aspects of your program that will most likely to change in the future. By understanding what your system performs, you will know, oh, I need to change this function in my future. So what you will do is, you will encapsulate that function in a separate module or class. So by encapsulating this, you will do the code which is easier to maintain. Okay. So example is, you are working on a payroll system that calculates the salary of the employees. Now, the payroll system is calculated based on the job title and years of service only. But you will know the company very soon change the calculation method. That is, it is planning to introduce new scheme, that is employee performance also. So, method of calculation will going to change in the near future. So according to this principle, you have to encapsulate the salary calculation logic in a separate class or module. This is what I mean by encapsulate what varies. What you are going to change in the future will encapsulate in a separate class or module. So it will become easier to maintain. And the next thing is program to an interface, not an implementation. That means software components should based on the abstraction rather than the concrete implementation. This is what you have seen on the solid principle for O for open or closed, and D for dependency inversion principle as well. Here also you make the abstract. That means you have created the interface. You are not dependent on the concrete implementation. You have just passed the interface for the class, and then in the client code only you are calling what you are needed. So this is the same concept here also. Software components based on the abstraction rather than the concrete implementation. So it will less dependent on the specific implementation. So, for example, use interfaces to define behavior of the components. For example, you are creating notification service. So notification is created in interface, and thereafter you can be able to make the concrete implementation for push notification service and mobile notification service, email notification service, and etc. So like that, you can able to do that. And the fourth one is favor composition over inheritance. First, you need to know what is composition. Composition means complex objects are built from the smaller, simpler components. That means you are building a larger class by using small class, small specific tasks. For example, let's say you are designing a computer system. So instead of creating a single computer class that contains all the functionalities, you will break down into smaller components such as processor, memory, and storage. These are the three different classes: processor, memory, and storage. And you have made this complex class computer by using these smaller three classes. So you are building a large complex class by using the smaller classes. So you have to focus on composition over inheritance. Because of that, you will build the more reusable code. You should not rely on deep hierarchy level. You should depend on the composition. That means rather than relying on the deep hierarchy, that means hierarchy with the 4 or 5 levels, you should need to make it with the composition method. And the next principle is the dry principle. Dry, D-R-Y. That means don't repeat yourself. Here, the word also suggests that you should not duplicate your code. Instead of that, you need to build a reusable code. Try. Don't repeat yourself. Don't repeat yourself means you don't need to repeat that code. That means you should not duplicate that code. You have to make the reusable code and use it everywhere. You just call it everywhere where you need. Instead of writing or instead of copy pasting it everywhere. The next principle is KISS principle. That is KISS means keep it simple, stupid. As the name suggests, your solutions should be simple as possible. Your simple solution should be understand, maintain, and modify easily rather than the complex functions. So make your system more simple and stupid. That way you will build a more maintainable, understandable, clear function. And we are going to study about our last principles, that is YAGNI principles. That means YAGNI. That means you ain't gonna need it. That principle states that developers only implement features when they are actually needed, rather than trying to anticipate future needs and adding unnecessary complexity to their code. That means you will not think, I will need this requirement in future. You will not anticipate. You will not make any predictions about the about future. You are just building according to the current requirements. You are building the system according to the straightforward requirements, according to the Harvard requirements. Don't make any unnecessary features and functionalities by anticipating future. That is, you ain't gonna need it. That means only implement features when they are actually needed rather than trying to anticipate future needs. Okay? this is my own article, and I'm going to attach this article with this below the YouTube in the reference sections. So you can refer these articles if you want. And if you have any doubt, you can contact me over my LinkedIn. And this is my LinkedIn address, Stebana Govindaraja. Okay, now you can meet me on my next video in design patterns. By the way, bye bye. Thank you so much. And if you forget to subscribe, please subscribe my YouTube channel as well.